Hello, everyone. My name is Baldwini Adobadu, and my project topic is forecasting interest rates using the naive model. The goal of this project is to enhance investment strategies for various economies or specific economies through improved interest rate predictions. Let's now delve into the introductory part of the presentation. Now, forecasting interest rate is very critical for financial markets, and over the years, a lot of people have wondered how most businesses have been able to thrive in such circumstances. Now, one of the biggest takeaway from this project is that interest rates forecast drive investment decisions globally, in the sense that whether businesses are deciding where to invest, government setting monetary policy that is controlling the amount of money in circulation, or um, individuals making borrowing or saving decisions, reliable interest rate forecasts are very essential. That is, they influence how money moves across the world, shaping everything from local economies to global markets. And now the research objective for this particular project is that we're looking at the method that would provide the most reliable and actionable predictions. And it is also important that we note that if we test across different models, it will help us to make sure that the final choice that we come up with is based on accuracy and practical performance, and not just about complexity. So it is very important for us to also take note of that. Now, the key finding is that for this particular project is that we're going to use the naive model because that is what this demonstrated superior performance. And I'll go into details in the subsequent slides. Now, the background research, we're going to look at the economic impact, the methodological approach, and the model selection philosophy. So, what happens is that when interest rates rise, borrowing becomes more expensive, which tends to slow down spending and investment by helping to control inflation. And also, on the other hand, when interest rate falls, it stimulates borrowing and investing. That is at the end of the day, it speeds up economic growth. So being able to forecast interest rates accurately is very crucial. Is very crucial for understanding both the inflation trends and how money will move through the economy. So for this project, I use the time series analysis as the core methodology. And interest rates, it is also very important for us to know that interest rates in particular are very time dependent. Okay, so without using a time series framework, important patterns like trends and seasonality could easily be missed, making forecasts much less accurate. And now with a model selection philosophy, of course, we want a model that will give us a very accurate result. Okay, so a model that is very simple enough to be understood and applied by policymakers, investors, or business leaders is what we are looking at. Now, the problem presentation is also very important to know. It is very important for us to know where the problem is emanating from. So now the market volatility challenge. So whether interest rates jump or drop unexpectedly, businesses delay expansion. So consumers hesitate to borrow, investments also pull back. That is, investor confidence is lost, and they pull back from making big decisions. So this unpredictability adds a huge amount of risk into the system, and this can also slow economic growth. And as a result of that, the environment of investment will be very shaky, and investment would normally pull back when that happens. Now, the specification and design for this project. So for the model selection, I evaluated three complementary forecasting approaches, and that is the naive model, the ETS, and the ARIMA. And for the data allocation, I divided the data set into two clear periods. That is a training period from 2010 to 2022, and a test validation period is I used the entire year of 2023. So the training data from 2010 to 2022 allowed the model to learn from a wide range of economic conditions. That is, we're looking at the growth, the slowdowns, and the fluctuations. Now, I also validated the models using completely unseen 2023 data, and in evaluating that, I prioritize two key metrics. That is the mean absolute error and the mean absolute error and the mean absolute scaled error. That is the two metrics that I use. And I also use the statistical environment as the primary tool for my analysis. Okay, so with the data acquisition and preparation, I gathered monthly interest rate data spanning multiple years. So the data was collected So the data was initially collected from 10 diverse economists, which covered economic cycles for a 13-year period, ensuring a broad and representative sample that captures different market behaviors and economic environments. So the data set was also complete with no missing values across all periods. Yeah. So it is very important to also pay attention to missing values, because in the data where there are a lot of missing values, it means that it's going to affect the results. So in that particular case, you need to clean the data to have a very good data to do your analysis. So the completeness is also crucial, because missing data can introduce bias. It can also distort the model and also weaken forecast accuracy. All right, so with the data exploration, first of all, we look at the trend analysis. And one of the first insights from the data, as you can see, is very evident, was identifying a clear upward trend. So throughout the observation period, we can clearly see that interest rates consistently showed a steady increase over time. And also with the cyclical patterns, you can see that the seasonal component showed a repeating pattern at similar times each year, indicating that the interest rates are not only trending upward but also moving cyclically. And also to validate that our time series was suitable for forecasting, I performed the stationary test by using the ADF test, and the test results showed that the p-value was less than 0.5, which means that the series is stationary and ready for accurate modeling without needing additional differencing. Now, with the data transformation, the daily fluctuations also revealed meaningful monthly trends, and the stationary was also dealt with. And with the seasonal decomposition, we realized that patterns were isolated for improved model parameter selection. Now, the motivation for the technique choice. So I made mention in my introductory part of the presentation that the naive model was selected, and it was selected because it proved that it has the least error when it comes to comparing that with the other models, that is the ARIMA and the ETS. Now, avoiding overfitting is also very key in a key challenge in forecasting is avoiding overfitting. And to prevent this, I made sure that all the models were evaluated on independent 2023 data sets. And this separation ensures that the models are not just memorizing past patterns, but are genuinely able to predict future values. And it also, as you can see, it also prevents data leakage, where information from the future could influence the model's performance inappropriately. And by testing the models on the fresh data, we can most times confidently say that the results reflect true predictive power rather than overfitting to the training set. Now, the model performance evaluation, among the three models that I evaluated, that is the naive, exponential smoothing, and ARIMA ETS, the naive model surprisingly delivered the lowest predictive error. So as you can see, the naive model had, for the MAE, it had 1.59, as compared to the ETS, which had 1.68, and the ARIMA to 1.68, and the MASE also had that naive at 0.59, ETS 0.63, and ARIMA also had 0.63. So despite the naive method being the simplest model, it's in this particular model performance evaluation, it's outperformed the ETS and the ARIMA. Now, we look at the visualization of the results. So we look at the model fit verification, the forecast validation, and the statistical diagnostics. All right, so the actual versus the fitted. This chart compares the actual monthly interest rate. So the solid black line shows the actual monthly interest rate with the naive fitted values, which we can clearly see the blue dotted lines, which happens to be the training period from 2010 to 2021. So as you can see, the naive model closely follows the actual data, replicating the overall movement patterns and volatility and the volatility as well. So let's also notice how the fitted values, despite being a simple forecast, still manage to mirror the seasonality and sharp fluctuations, especially during periods like 2015 and 2020, where major drops occurred. Now, the forecast versus the actual. So the naive forecast versus the actual interest rate. So this chart shows the performance of the naive forecast compared to the actual interest rate for the test period 2022 and 2023. So the black line represents the actual observed interest rate, while the red line shows the naive forecast, which assumes the interest rate will stay consistent based on the known value. So as you can see, the actual rates fluctuated significantly over this period, especially during the mid 2022 and the late 2022, whereas the naive model remained flat. Okay, so with the ACF plots, once the models were trained, we conducted the residual diagnostics to confirm the model's effectiveness. So I used the autocorrelation function, so the ACF plots, to check the residuals. So the ACF plots showed that the residuals were indeed random and patternless, confirming that the model had captured all relevant information in the data. So this means that no significant structure was left for the model to explain, which validates the adequacy. Okay, so the residuals of naive forecast model. So this plot also shows that the residuals from the naive forecast model over the training period from 2010 to 2021, and ideally we want these residuals to fluctuate randomly around zero without any clear pattern. So as we can see in the chart, these residuals are quite volatile, but they don't seem to be centered around the zero line, which suggests that the model is unbiased on average. So however, the large swings also indicate high variability, showing that while the naive model captures the general level, it struggles with the month-to-month movement. Okay, so the forecasted interest rates for 2024 and 2025. So the graph displays a completely red line at approximately 9.49% for the forecasted interest rate from January 2024 through January 2025, which typically assumes that future values will be identical to the most recent value. And the perfectly horizontal line also indicates no predicted change in the interest rate over the entire forecast period. So this suggests that a very simple forecasting approach that doesn't account for economic cycles and policy changes or other factors might influence the interest rate. All right, so in conclusion, the model model performance, we can say that the naive model, for the naive forecast model, demonstrated surprising effectiveness, and it also outperformed the ETS and the ARIMA model by showing low error metrics in its performance. And also with the methodological advantage, we can say that it is very simple to use, and it also enables rapid deployment and clear communication. Its transparency helps stakeholders to understand and also focus other metrics. And with the limitation of the naive, it's a model that cannot anticipate structural economic shifts, and it also assumes persistence of current conditions. So sudden policy changes or economic shocks would compromise its accuracy. So the final thoughts and future work is that in order for us to get the actual or accurate results, we can also include other macroeconomic factors like the GDP, inflation, and unemployment values or data, which would provide in a more broader context a very good outcome for our project. Thank you very much.